Hi all, my name is André and we are here on this second video to continue talk about DMVPN. The first video we talk about how we implement the tunnel interface, and now we will talk a little bit on part 2 about the IPsec implementation. Okay. So we have here on this first slide the agenda of today, and let's go ahead. We have seen on security implementations many acronyms. So probably you already have seen one of these acronyms during your work, and many of them can cause us a mess and to understand how this IPsec implementation can be done. Here we have what is the IPsec, ISAC, KMP, and IKE acronyms. IPsec, that is Internet Protocol Security. ISACAMP, that means Internet Security Association and Key Management Protocol. And IKE, that is Internet Key Exchange. IPsec is a framework of open and standard technologies used to ensure private and security communications over IP networks. ISACAMP, it's another framework for authentication and key exchange, and is designed to be key exchange independent. And for last, the IKE protocol is used to set up a security association in the IPsec protocol framework. Let's see the next slides, how those protocols works, okay? Okay, first of all, we have here on the top the IPsec that is integrated with ISACAMP and IKE version 1 and IKE version 2. The key points of all these protocols is reliability, integrity, and privacy. That is objectives of the IPsec implementation on the DMVPN. This IPsec structure is divided in two phases. Phase 1, that will make the tunnel interface secure, and phase 2, that will make the data that will use this tunnel secure. For phase 1, we have the authentication method, the cryptography algorithm, and Diffie-Hellman groups. Okay. On the second phase, we have the hash algorithm, cryptography algorithm, and Diffie-Hellman group 2. So just to remember, phase 1 will be worry about the tunnel security and the metadata that will be exchanged between the routers to guarantee that you are talking with the correct router, that you are talking with security, and your data will not be its security and not be changed in the middle of the way. And phase 2, of course, I told you before, is to make the data of the customer security. Let's Okay. Just to with a more generalist view, I try to represent on this slide the relationship between the protocols. Okay, IPsec framework make use the ISACAMP, ICE version 1 and version 2 to guarantee the three base key points that are reliability, integrity, and privacy. Reinforcing that phase 1 will guarantee the metadata exchange between the peers to be established the tunnel is secure, where reliability is to be sure that you are talking with the correct peer. Integrity is to be sure that the messages between them were not modified, and the privacy is to be sure that it's totally secret and no one is able to read the message. On phase 2 is to guarantee the user customer data is secure. Same phase 1. We have here the kickoff, that is the step 1 when the interesting traffic initiated the IPsec process. This traffic is deemed interesting when the IPsec security policy configuring the IPsec peers starts and the ICE process. We have here on phase 1 the negotiation steps. We have here an initiator router and a responder router. The initiator router will send MM1 packet with policy proposals to responder routers that will reply to us with a MM2 packet. Before that, the initiator router send a MM3 packet where is included net discover if we use it, and the DH exchange part. The responder will reply with the MM4 packet, continue the DH exchange. Before that, the initiator go to send a MM5 packet with the local identity information and the keys, and the responder reply with a MM6 packet. So after all these negotiations, we have phase 1 finished. We can see here on man mode 1, MM1, initial proposal for IKE that include encryption, hashing, Diffie-Hellman, that is DH group, and lifetime. We will see on the next slides how make the configuration and how it's is integrated with these negotiation steps. Here we can see the line commands to create the key ring, that is the key used on MM5 packet that we saw on the last slide. So let's click here, and here we have the script line configuration for IKE version 1 and IKE version 2. You can see the FVRF that can be used if your scenario make use of front VRF. Now you see the lines command to create the policy that is used on man mode 1. Just to remember, is on man mode 1 that initiator router sent the policy with encryption, authentication, and Def-Hellman group. For last here, we have the ISACamp profile for version 1 and for version 2. Now let's go to the next slide to see, let's go more deep. So we have here the first command, that is the key ring, and on this slide we can see where we will, well, where are the parameters that we should customize with the name of the key ring, the VRF parameter, front VRF parameter, if is used. It's interesting here, the pressure key address. When we use 000, seems like any IP can, any IP, no matter what the IP the spoke router is using, if the spoke have the correct key, he can be a client on the DMVPN. So specify the IP address and mask of the peers on this case means any IP. You can see on the bottom here an example with specific IPs on the spoke routers. So if you have an internet connection with a stable IP address, fixed IP address, you can be direct and specify exactly what IPs can be a client on this DMVPN cloudy solution. We have here to IKE version 2 implementation. Let's go to the next slide. On this slide, we have the policy proposal implementation with the priority, the cryptography algorithm, the authentication, that in this case is press-share because we are using a press-share key, and the Diffie-Hellman group. We did this configuration for IKE version 1 and one example of IKE version 2. The last part of the configuration is the crypto ISAC IP that we have here. Pay attention on the VRF parameters that for inside VRF are into a front VRF. Okay, usually on the inside VRF is only used for crypto maps. Okay, pay attention the permitted peers where 000 means any IP. The local address is the ISP interface, the same interface used on the tunnel source command. So the IP address on this interface will be used as identity to be matched on the peers. Okay, After phase one, we have here phase two slides, the transform set that should be used, the IPsec profile, uh, take a look that with the last command set ISA camp profile, without this command, the router will try the IK version 1 as the first method, okay? And for last, how we can implement this IPsec profile on the tunnel interface. Take a look on the shared word that is used when many VTIs, virtual tunnel interface, use the same IPsec profile. Here is another slide with a little bit more deep with an explanation about all the parameters that we configure on the IPsec transform set. Take a look here on the mode transport, that transport mode will encapsulate the payload only, and the tunnel mode will encapsulate all the datagram IP. Okay. Here we have the IPsec profile with the transform set information and the IK version 2 profile on the bottom of the slide. Here we have the last command is where we implement the IPsec profile to the tunnel interface. So if everything working properly, we will have the tunnel IPsec communication between the sites working properly. When the communication is finished, the IPsec as A is terminated through a deletion or by timing out. So the timing out and the tunnel is automatically deleted. Here we have a scenario with a dual hub and a front VRF. You can see the scripts and the line commands for IPsec configuration on IK version 1. Here we have the same scenario, but using the IK version 2. On this slide, we have a little comments that we can use for troubleshooting. We need a pay attention that IK version 1 and IK version 2 cannot share the same underlay interface. So if in your router you use both technologies, IK version 1 and IK version 2, you need to have an understanding that you need to have two different interfaces, one for each technology to use as an underlay interface. Do not learn or publish the underlay IP via the DMVPN tunnel. this will make the DMVPN tunnel flap. So you need to pay attention when you implement the routing on to be used on the tunnel interface. So that's it. You can send me question by email or using the Skype for Business. I will answer you as soon as possible. And of course, more material you can take a look on ablongbr.blogspot.com.br. Thank you very much. See you next video.